Okay, recording is started. Okay, so it's ongoing. So yeah, last time we talked about polymorphism. This is the, maybe I would say, the key part, the main part of object-oriented programming. Since we talk about the object, so we need to so it means that we have the separate units based on the classes defined. And the thing is that we have the inheritance. Yeah? So we talk about the inheritance. Yeah, we know that we can extend one class from another class. Yeah, so it means that, again, as I said, it first of all, and secondly, and thirdly, it means that we extend the superclass. You know, we have the class, we define the subclass, means that we extend, we add more features. But it means that, like, if you add something, you add something more, it still has all the properties of what was taken as the base. And same as in programming, when we extend the superclass, we actually then add something more, yeah, to the new class, and still all the properties from the superclass are in place anyway there. Yeah. So it means that all the subclasses are also they also have everything from the superclasses. Yeah, this is the point, and this is why we talk about polymorphism. It means that we may work with one type of object. I mean, usually it means that we use the variables, yeah, variables or other data structures, and then we simply store the objects under them, the instances of the objects, the references to the objects in memory, and then the polymorphism means that we actually store some actually under one variable, yeah, with variable with one exact type. There can be objects with multiple different types, which again we'll talk about casting today, which means that they can only be can have the same type as the variable is defined if it's the full class, not abstract class or interface, or they can also be the they can be the subclasses of this class. And we had a great example. What was it? Moments. This one. Yeah. So the key part is that you see that we define the variable, multiple variables. So or one variable, doesn't matter. The variable has one exact type, but the object passed to this variable has another type. Yeah, and as I just said, this class, this type can be the same type or the subclass of this particular class. Or if this is the interface, I'll talk about the interfaces, then we can also define the variable with type, which has the type interface, and then we cast the subclass, the class which implements this particular interface. Yeah. So this is the point. Yeah, and the key part is that here again everything is defined. We actually can follow what is written here, but remember, on practice this will not always be possible. Yeah, that you see that ST is actually sales tax. Most likely this will be hidden in some way. Yeah, hidden in some way. That, for example, it usually means that you have one class. Yeah, so let's say that you have one class, one method which processes sales. You have sales objects, and it actually means, and sales objects can be passed to the method you defined. And so this means that your method can be used from everywhere. Yeah? Let's say that it can be used from many places. Yeah? and then in each of these ways there may be different scenarios, yeah, and they will then send the different type. Yeah, so like again, method, one place method processes all the sales, then this method is called from many different places. Again, even again, as I said, most likely that you are not alone who works on the project, so it means that there may be many different developers who do it, especially if this is the framework, then the framework is something generic, then others can use this framework, others can extend this framework, and then the methods what are defined with one type, they can actually be used from other pieces of the application which have another type. Yeah. So this is the point. Yeah, the point is you will most likely you will not see, in most cases you will not see what is the type of ST. Yeah. Also from my experience, not sure if I do have, okay, I don't have this code right now, but yeah, there's some not so good programming approaches used where, for example, yeah, there are the frameworks. Usually there are the frameworks based on the objects. Yeah, there is some kind of object layer, yeah, object definition, and they have the entities of these objects, and the objects are related with each other. For example, let's say that you have the object, yeah, you have the object page, yeah, so let's say that this is the programming object, the class which represents the pages, so you have the web class which represents the web page, so it contains all the necessary information about the web page, like all the layouts, all the components it has, and then this particular page can, okay, it can store these, yeah, actually this is a really nice point. Yeah, I want to also mention, yeah, this is, I would say this is maybe more relevant for this particular case. Yeah, so I'm just talking about, so let's say you have web page or you have a car, and there can be multiple ways how this logic, let's say has a can be implemented from technically how it can be implemented. As one example, this can be implemented as direct components. And so let's say that it has direct components. Yeah, so components of the class are engine and wheel. Yeah, so we have the class, and let's say we have two attributes. That would be correct, that would be fine. But on the other hand, what can be done, how they can be technically stored? Let's say that car has the collection of all the components, we usually call them relationships, to this particular object. Yeah, so it means that car as the object may have the related entities. Yeah, related objects. Again, it's not mandatory that these relations are the part of the car class. So let's say that what kind of relationship car may have. So it may have, again, engine as the related entity, or also wheel may have as the related entity, or we can have also mixed structure. Engine and wheel are the members of this object, but let's say that the car may have the relationship, I mean, related entity would be the owner, yeah, owner of the car. Yeah, so it is also the relationship, yeah. Car has an owner, yeah, and means that car has the relationship, yeah, related entity. Then what else? Car may have driver as a related entity, and so on and so on. Yeah, so there is a structure that we define. Again, it can be stored under the car object or somewhere nearby, we define the relations between multiple objects using the relations, and then we get the entities. So, and if we go back to this example, what I just said about not so good programming techniques is that actually, let's say that there is one variable, and yeah, in practice I faced the situations when actually one variable is used multiple times, and so this is why I just talked about the relationships. For example, let's say we have the variable which can store all the relationships, and on practice I faced many times the situation that I see the code which actually is written in the way that yeah, maybe I will write it in Notepad. So let's say that we have entity, yeah, because I don't want to define these objects. So let's say it doesn't be entity. Yeah. So this is some kind of entity. Yeah, we get from somewhere, and then let's say usually sometimes I see this such code entity, like entity equals get related entity or something like this. And so then you provide relation name, and then you call it. Then again, entity equals get related entity again. So you do something like this, and you may do this like several times. And of course, such approach may trigger. Of course, this way this will work. This will work, and if it is written at least like line by line, then it may be possible to follow what's going on here. Yeah, but the thing is, as you can see, that of course, if one variable is used for such approach, then at some point, usually what happens, at some point I ask the question, what the entity is, yeah, what does this variable store, yeah, what is it now, yeah, because here the variable is, let's say it can be like, from our example, it is a car, then here it may be car has relationship, let's say that we get relationship, let's say, okay, maybe let's just write dummy logic here, so it could be new car or something like that, yeah, or just any car, yeah, then we have somewhere the car, then let's say that entity get related entity, uh, that would be, let's say, this would be the relationship, let's say, the owner, yeah, then the owner, then from the owner we can get related entity, that would be maybe children or something like that, yeah, then children, so we can get from children, then maybe teacher, or I'm not sure, yeah, maybe something like that, yeah. So, and then of course at this point entity is the car, at this point entity is the owner, and at this point entity is children, yeah. Oh, sorry, teacher, yeah. So of course, yeah, so here it is car, here it is owner, here it is owner, here it is children, here it is children, here it is teacher. Yeah, so something like this you may face in at some point in programming. Again, this is just dummy logic, but in practice this may be something wrong, because again, for example, if you work with a website, you see there are multiple components. These components technically can be stored as processed as the objects, and then each component has a related component, and then actually they have some kind of relations between each other. So yeah, you see, if you use one variable, polymorphism works well here, but from the point of view of clean programming, this of course may be not really clear, right? And so this is just example. This is just example how this can be implemented on practice and you will see. And this is actually, I'll say, the bad side of polymorphism, but also the relevant point you may face in practice. So please be careful here. Okay. So yeah, this is what we have, and yeah, as I said, the subclass should have all the properties the superclass has. However, it is possible, yeah, as we discussed, it is possible to override the methods of the superclass, which means that you can define different behavior for the subclasses comparing to the superclasses. Okay. So yeah, that's why it means that if we override the method, then it has different behavior than the one automatically inherited from the superclass. If we want to make the overriding available for the subclasses, then we need to define the method as virtual. Yeah? Then it means that we can override it in a subclass. And there is one point one keyword what we can use is the keyword new, which actually means that if we use new keyword under the method, yeah, so new keyword can be used for virtual methods, and comparing to the override, yeah, so we have two options. We can three options. Sorry, we can do nothing. Yeah, it means that the method from the superclass will be used for the subclass. Yeah, it will be just simply reused. Then we have a second option that we override the method. It means that we create new behavior. And the third option would be new. It means that we do not override the previous method. We just simply create new method. Yeah, and the difference would be if we use polymorphism, if we use upcasting in this case, and instead of calling the method from the new method from the subclass, it will call the method from the superclass. So it will not override the method. It technically we can say that it creates a new one. Yeah? So yeah, this is what we talked about last time. Do you have any questions? Okay. If not, then let's move to the casting. Yeah, so casting is a key part of polymorphism. It is also directly related to the abstract classes and the interfaces we will talk about later today. And we actually already used it in the previous topic in polymorphism, but there may be some key points there. First of all, you need to sorry, one moment. This is the wrong presentation. Let me open the right one. Okay, yeah. So now it's better. Okay, this is the right one. So yeah. Yeah, we just talked about polymorphism, and as we've seen, one variable defined as one type can store the objects which have different data types. And then the thing is, the question may be, how can we actually pass basically what we can use as the polymorphism? Yeah. So what kind of classes objects we can passed to the corresponding variable. Yeah, and when the type of the object of the object is not the same as the type of the variable, then it means that we pass different types technically. And yeah, the only question is when we can do it and when we cannot do it. So first of all, remember that as I mentioned, the casting before, the casting in terms of object-oriented programming is quite different than the casting we did with the value data types. Yeah, because for value data types, the idea was, I would say, quite simple. That yeah, because normally value types means that we work with the numbers. Yeah, and it's quite simple from this point of view, that we can, let's say, if we have number with decimal values, then if we try to pass it to integer, then it means that we will lose the decimal numbers, decimal digits, right? And so if we want to put decimal value under the integer variable, yeah, of course, then the data will be lost there. On the other hand, we have the opposite. We can have the opposite situation. We can pass integer to the variable type, integer value to the variable typed as double, and basically what happens in this case, actually nothing is lost then, right? Since integer is also a double. Yeah, all the integers are doubles as well. So it's just a simple passing operation. So remember, if we want to pass if we want to pass more specific value to less specific, to more general attribute, variable, then we need to provide this casting procedure. Yeah, we want to say to the compiler that we are fine, that we can lose the data there. On the other hand, we have the casting in programming. In object-oriented programming. Yeah, what does it mean in this case? In this case, it means that actually I would say it's opposite one. If we because remember about polymorphism. Yeah? So I will go back to this presentation. Oh, sorry, not this one. This one. Yeah, and so every time we define we define inheritance, we can actually proceed with the casting here. So, and basically the answer is simple. When we can do the casting, we can always cast, like, let's say that if we have a general type, and then we have more specific type, then more specific type can always be casted to more general type. Yeah, and it's very simple if you think about it from the real life point of view. Yeah, so if we say that can we, yeah, so here we have this is a relationship, and again, what I said last time, is a car a vehicle? Yes, it is. Is a bus a vehicle? Yes, it is. So it means that car can be casted to vehicle, since car is a vehicle. Then can we cast bus to vehicle? Yes, we can, because bus is a vehicle. Yeah, so every time we can use is a relationship. Here we have, let's say, source variable and the target variable. Then we need to use this question: is the object stored under the source variable, is it the target variable? Yeah, so every time you do the casting, you need to ask this particular question. Yeah. Yeah, this is one point. Another point would be for the abstract classes and interfaces, but for them it is also, I would say, the procedure is the same, because let's say that vehicle implements the interface. Yeah, we recently worked with the interface comparable. Yeah, so it means that vehicle can be compared, and then it implements the interface comparable. But then yeah, can we cast vehicle to comparable? Yes, because vehicle implements comparable. Can we cast car to comparable? Yes, because the car is vehicle, and vehicle implements the interface comparable. Yeah, same as for the bus. But again, we cannot cast car to bus because car is not a bus and the bus is not a car. This is not possible, and also vice versa, it's not possible. We cannot say that vehicle is a car, and also we cannot say that comparable is a vehicle and comparable is a car. Yeah, so for the casting, it's we should strictly use this as a relationship. And yeah, and also it is important when we talk about, let's say, multi inheritance, but when actually we have multiple levels of inheritance. Every time we have, as I said, we have this top-down design. It means that we go from top to down. And so we have the base class, then base class is inherited by subclass, then another subclass can be inherited from the previous subclass. And yeah, so what do we have from the casting point of view here? Again, here we have the same as a relationship. Yeah, dog is animal, and bulldog is dog. And also bulldog is also an animal. This is also relevant since, like, if we have one particular class and it has, let's say, multiple levels of the superclasses, then we can always say that this class is also one of the superclasses of its superclasses. I mean superclasses from the hierarchy point of view. Yeah, hope you understand. And so it means that we can always cast bulldog to animal. So this type of casting is also acceptable because, again, bulldog is also an animal. Yeah. So this type of casting is also acceptable. On the other hand, we may have more advanced situation. Yeah, if we simply deal with such approach, that this will always be fine, and I hope pretty much clear. But let's say that we do the following thing. We cast bulldog to animal variable. Yeah, so it means that animal variable will now store the bulldog object. Yeah, that will be fine. That will be the option. But let's say that you then, so again, you just casted past bulldog object to animal, but then let's say you want to pass it back from animal variable to bulldog variable. But in this case, you see that is a relationship from the variable perspective. It does not work since animal is not the bulldog. Yeah. So in this case, we have a really, I would say, uncomfortable situation because animal is not bulldog. But here is one thing. Yeah, as I said, animal is not a bulldog, but it's not true for all the animals. Yeah, if the animal is bulldog or one of the subclasses of bulldog, then animal is bulldog for these particular cases. And in such case, it is actually possible then to pass bulldog object, which is stored under the variable typed as animal, to the bulldog variable. That should be possible. Why not? Right. So yeah, and in this case, same as in the casting of value data types, here we also need to provide this information to the compiler. And let's then define this situation here. Yeah, I will define several classes. I will not implement these classes just because it's not so important right now. Yeah, so let's say I have the class animal, and so I'll just simply define empty class. Then I define a class dog, which then extends the class animal. And then I say that I extend the class bulldog, which then implements the class dog, right? I'll do it. Done. Okay, so now we have three classes. Animal is the superclass of the class dog, and dog is the superclass of the class bulldog. And it is also correct that animal is the superclass of bulldog as well. And yeah, so this is what you also need to remember. Yeah, that animal is a superclass of bulldog class as well. So yeah, then let's say that we want to do the following thing. Yeah? Again, at this point, I will show you directly, just simply line by line. On practice, this may be more hidden. Yeah, it will be, as I said, you may have multiple different classes from many different places, and then sometimes you will not be able to follow all these castings and all these operations then. So that's why I will show it here, but please remember that in real life this may be more trickier. So yeah, then let's say I define the variable animal. Then let's say I define the object, the variable, yeah, let's say bulldog. Then I create new bulldog. And then, as I said, I can pass bulldog to the animal. And this is relevant case, as I just said, this is correct. And actually, how this is called upcasting. Yeah, remember I already used this term quite several times. Yeah, so this is called upcasting. Upcasting means that we cast the object from more specific type to more general type. Yeah, so I will then write it here. Cast the object from the variable. I'll say source variable. Yeah, I usually like to use this these terms, source variable and target variable. So when I pass the value from the right side to the left side, I call it that on the right side we have source variable, and then on the left side we have target variable. I like this term. Yeah, maybe on practice you will hear different terms, but I hope that these terms are clear. Yeah, that this is the source from where we take the variable, and the target one, where do we pass this variable. Yeah. So, and yeah, here we have upcasting, means that we go up. Yeah, so it means that we go to more general type. Yeah, so here we have more general type. Source variable, source variable which has more specific type than the target variable. Yeah, this is wrong case, and this is the case which is, I would say, quite simple, and it will always work. Yeah, um, since this is just, it will always work. Yeah, always work from this perspective. What I just shown you. Yeah, from the perspective of is A. Yeah, because we know that the object stored under bulldog will always be animal, and this will always be relevant. Yeah, so this case will always be true. On the other hand, as I just said, so we know that now, yeah, but remember one thing, which is really important. When we pass the object of bulldog to animal variable, then of course we now have the variable which is more general, but the object type still remains the same. Object type is still bulldog. If we pass bulldog object to animal, it will not change the object type stored under animal. Animal will store, yeah, it will store. Bulldog, it will be stored under animal data type, but the object, the type of the object itself, it still remains the same. Yeah, it will not be changed. This is a really important thing to remember. Yeah? So it will not be changed. It will still be the same. So it simply means that at this point animal stores bulldog. Yeah, it does not store animal object type. I mean just animal object type. It stores bulldog type. The bulldog object type. Yeah, and then of course, so here it's quite simple. Let's say I have some logic in between. Yeah, in real life that would be then this way, and then I want to pass the animal back to the object. Sorry, the bulldog, um, which is stored now under the animal data type to back to the bulldog variable type. So in this case, this makes sense, yeah, since we know that it is bulldog object stored under animal. So why can't I pass animal to bulldog? Yes, you can. Why not? But then you need to do the following thing. You need to then say that you cast animal to bulldog. So this is called downcasting. So it means that you go from more general variable type to more specific variable type. So so then I can just simply replace a few words here. Cast resource which has more general. Yeah, but again, here you only cast from, you cast directly based on the object type, which is stored under the variable, which has different type than the bulldog. Okay, and then I can run the program. You will not have any result, since this is just an empty program without any actions. So I want to run it. Sorry, change it. Why can't I change it? Okay, it's wrong. Let's try to build it. Yeah, okay, this may be the case. Okay, build is done. Let's try. Why it cannot be run? Okay, maybe let's run the previous program. Then let's try to run this one again. Later on. is running. Okay, still running. Let's close it. Why the current problem is not shown? Looks like. Okay, maybe let's try it from this previous one again. It's lagging out a bit. Okay, looks like today it does not want to run. Okay, we have. Okay, then we usually have an alternative option. Alternative option would be that I go directly to this folder and I run the program from here. So as an option, let's then do it. I will restart maybe my Visual Studio during the break, so you can then proceed in a better way. Okay. So a moment, I will copy paste the folder. So this is always an alternative option. I can run it directly from console. I can run it on .NET Run. Okay, .NET. Yeah, so the program run, no problems, no exceptions here. Yeah. So in this case, everything is correct. And this is correct case. But let's go to another option. Let's say that I define a new variable. Let's say animal. Let's say real. Like that. And then I assign the type animal. And so now I pass animal to animal. And let's say that I want to cast animal real to the bulldog type. Yeah. So in this case, this will not be correct. Not correct because animal the object, yeah? The object reference stored under animal real variable is not an instance of bulldog class. Yeah? So let's run the program now, and we should get the exception now. Yeah, so we have our node exception, invalid, cast exception. So how to solve this situation again? Because in real life, when you use downcasting, this will always mean that, usually this will mean that you actually not know the real type yet. You may have, again, for practice, you will have multiple different classes from multiple different places, and you don't you won't know exactly what does your method receive. Yeah, if it receives bulldog or if it receives another animal, yeah, it's maybe it will not be, you will not know it directly, most likely. Then what you can do, There are several options. Firstly, you can always use try catch. Maybe maybe like this, and then you can use this exception as an option. Yeah. So exception type would be invalid cast exception. Yeah. So in this case, of course, this will catch this exception and everything will be fine then. Let's run the program again. Okay, we have the warning. Okay, we have the warning. That exception is defined but never used. And this is fine. We can skip using this, skip defining it. Wow, my build failed. What's wrong? Why it failed? Sorry, yeah. I accidentally deleted the bracket. My fault, sorry. Yeah, so now we don't have exception because it is simply handled here. Yeah. So that would be the one option to solve the situation where you're not sure if you can or cannot cast. Yeah, and sometimes it may be possible, like you have without cast exception here, then you can try another type. Yeah, so for example, you try to, so here you try to cast animal Rio to bulldog. So let's say that here I can, and then at this point I know if bulldog is not it's not so if the animal is not a bulldog, then I can write the exception, and the exception then would be that I use another data type there. So and then I try another type. Okay. So at this point we know that the cast was unsuccessful. So we try another option. Yeah. Sorry. Yeah. At this point, I don't. The program does not know this step, so let's maybe define it outside try catch. Yeah. So remember about try catch. The problem is that it again it uses the blocks, so it means that if you define something inside try or catch, it will not be available from outside the block. Yeah, so that's why if you want to use the variables inside multiple blocks, then you should define them outside these blocks. Yeah, these code blocks then. Okay, and then we can, so as an option, we may have a situation when we simply try something different in the catch section. Yeah. So that is the relevant case, and on practice, this is usually used. Yeah. If we try one option unsuccessful, try another option, then proceed another way. That will be relevant case as well. So this is one point, one option how to handle this case. Another option would be also quite simple, I would say. I can use I can actually check if I can or cannot do it. So then the check would be the following. I actually ask, is animal bulldog? Yeah, so I can check this. Yeah. So check if animal is so I'll say is bulldog, or maybe that would be more precise, that would be or any subclass of bulldog class. Okay. Animal. Yeah, and then this will prevent the casting. Yeah. So same as here, I can actually check if animal real is bulldog. Yeah, also check it this way, and this will work. Okay, so do you have any questions about casting? Is it clear, or something needs to be described more, maybe? You're still here. So it's like, I know it's Saturday, it's hard, but still. Okay. Okay, then if you have any questions, then you can always ask. Yeah, then again, okay, see Owen and Maria are typing. Okay, so let's wait. Yes, I can also write the questions in the chat if you want. Let's see, Owen is writing. Let's wait.
I think questions will appear when we will try to do it ourselves.
Yeah, that's true. Yeah, I mean, I currently
That's
see,
all.
yeah, I mean, I currently see in chat that
In your case, it says, "Oh yeah, it's working. Very nice."
no, I mean, usually we always want to achieve that our program works, and then the key rule of programming is if it works, don't touch it. And this is relevant in all the cases, especially when you have a program which was developed like maybe 20 years ago. Then of course it's the worst idea you can imagine that you actually try to change something in the program which was developed 20 or more years ago. Yeah, no, it is maybe not the best idea to do. So if it works, then we usually don't touch it. That's correct. Yeah. Okay. Question from Alina. Maybe a question. Maybe you could give some kind of specific example when we would use casting. In this case, I would say the best option would be if I mean we need to have a real example from some kind of framework. I mean I can explain this, but at this point I don't have any examples, direct examples I can show. But again, the thing is that let's say I will show this schema, something similar. So let's say that you developed the method. Yeah, so you developed the method. So this is your method. And where is this? See, I want to have it as a solid. Oh, sorry. Change. Yeah, shape. So let's say this is your method. Yeah, you developed your method. So let's say that this method processes the products. Yeah, so you have the say this is the shop. Yeah, so this is, yeah, as an example, you have the program which works with the shop products. Yeah, so you sell, let's say you sell computers, you sell phones, you sell headphones, and basically all the possible products. Yeah, so let's say that you do it. Then let's say you create the program which is responsible to process all these products. Like let's say that customer orders the product. Yeah, then what you need to do, you need to calculate, you need to check availability, you need to check the price, you need to check quantity, and then you can actually submit this order. Yeah, so as an option. Then your method. So then there is let's say there can be multiple sources. Yeah, so for example, this can be your online shop. Yeah, the program which works with your online store. Then this would be the program which works with let's say maybe different online store, or maybe some kind of, I'm not sure, eBay, Amazon, or just something similar. Yeah, so that would be another store. Then this would be, let's say maybe your local store. Yeah, so local store, yeah, I mean physical store. Yeah, so then let's write, and then that would be your website maybe. Wait, it's too much. Oh, maybe that would be okay. So this would be your website. This would be, sorry, text. This would be uh, kind of site store, site website, web service. Yeah. And this would be physical store. And yeah, so this is the program which is responsible for the website. It can also be the part of your application. Yeah? So let's say that it is all located inside one application, and there's one part of application used for the website, and the part of application used for the some kind of site web service, and another part of applications used for the local store. Yeah, all these applications, let's say they are stored in one application. They are based on the classes, so you write the code for them inside the classes, and yeah, then you do all these things. And then let's say that they all have the products. Yeah, they all have the products, but let's say that, yeah, so then the class of these products would be product class. Yeah, so we have product. Yeah, maybe I can also write it and write dummy code. Yeah, we'll not write real code, but let's say I write dummy code. So maybe I'll comment out this code and I'll write new dummy code then. So let's say I have a class product, or maybe I'll write some kind of maybe plus minus real code, or at least which looks like as a real. So let's say we have a product, and let's say that the product has the price. Yeah, maybe let's use this approach here. Public integer price. Then we define get and set. Yeah. Yeah, what was I usually what was this range? So I usually miss the syntax for this. My fault. Moment.
I think the last semicolon is too much.
Okay, yeah, that's correct. But yeah, I mean, usually semicolon. Usually it should not be prohibited to use semicolons, but okay, yeah, thank you. Yeah, because this is the start of the block and this is the end of the block, and after the end of the block we don't use semicolon. Yeah, thank you. Thank you. I just missed it Saturday, so something like so. Yeah, so let's say we have the price, and then what else we can have? The quantity. Yeah, also is an option. So let's say we have the price, we have the quantity. So let's define get and set. again. Just add it, sorry. Okay, and then, okay, the thing that would, okay, maybe also, let's say, yeah, I think that would be enough. That would be enough. And then let's say we have the product. Okay, let's say we sell. Full. That will be the product. Not sure what kind of product we can eat. Just let's say that would be water. Yeah, that would be water. And the water may, so that of course also be the subclass of the class product. And then in addition to price and quantity, we can place volume. Yeah, so that would be volume. So get and also set. Yeah, as an option. And then let's say we have the class which represents computer. Oh, sorry, yeah. Yeah, let it be computer. Why not? And then yeah, it also extends the class product. Okay. Yeah, so okay. And what else we can add for computer as an addition? So what we can add to the computer? Might be maybe warranty, I don't know. Yeah, so maybe, yeah, what would be warranty? Why not? Public integer years for, I'll just simply say what be warranty. So I hope you understand that that being years. That set. Okay, so okay, here we define then everything in one file, but on practice, let's imagine that these all are located in separate files. Yeah. And then let's say we have another file which actually takes these processes, these products. Yeah, so let me define another class that would be shop. Yeah, so shop is not related to products directly, and then let's say that we have the basket. Yeah, so let's say we have the basket. I will store this as the private let it be array list. Why not? Yeah, it needs to then include using system collections. Maybe let's use swing. No, let's use array list. Okay, that would be array list, and that would be basket products. Basket products, and then I would find I will define methods. Public, let it be basket product. Oh, yeah, okay. That would be public what adds product. Yeah, and then we can add the product to the basket. Oh, no, sorry. Yeah, one more thing. I want to then calculate total price. So what would be? Sorry, price is integer, so maybe let's define it as double. Okay, so it will be private double total price. What would be public? Maybe public double total price. No, so what would be private? Since I don't want to use publicly, maybe total price. Okay, and then before we add product basket, what we can do, we can then calculate total price. Then that would be this total price would be product quantity times product price. Yeah. So. And so, yes. What else? Oh, hold on. Yeah, one more thing. And here you will see where we can actually use then the casting. Plus equals. So yeah, because I want to add the price, what we take from this product to the total price. So of course we add the price we calculate from here to the total price. Yeah, this is why we need to use plus equals. Yeah, and one thing. So let's say, for example, for computer, we want to. One thing. What would be public, and I would say public boolean. And additional warranty. Yeah. So for example, when people, I'm not sure. I haven't done it for a long time, but when people buy computers or something similar, then I guess there's the option to buy extended warranty. Yeah. So let's say that this parameter will show if the customer wants to buy extended warranty or not. Yeah? So let me extended warranty, and I will hold on. That would be get and set. Yeah. So as an option, and so what else I can do? I can define the price of standard warranty. Price. Oh, sorry, that would be double extend. I would say maybe this way. Warranty price. Yeah, and this will also be used getter and setter. So okay, this is done, and add product. Okay, maybe let's do it this way. I'll say that this product will add it to basket. Yeah. Add product to basket, and okay. Yeah, and then I will maybe add another method which will simply add product to catalog. Yeah. So then maybe I'll write another method. Array list get. Oh, sorry. Array list. That will be product catalog maybe. Why not? Yeah, and then I have public, and this will add product to catalog. Yeah, so we have product catalog and we have the basket. So add product to catalog. Yeah. So again, this is just maybe dumb example, but I hope after this you understand it better. So and then I will add this product catalog, and I will add this particular product there. Okay, so we have computer. Yeah. Okay. So right now let's implement. Oh, and one more thing. So and here we have this particular point. And where do we need the customer? First of all, we already, so let's say that now we have the customer which goes to the shop and the customer adds the product to basket. So you see, we use product, but we can put also water and we can put computer. So of course, let's say we have more product types, but right now I will not define them. I hope you understand the idea. Yeah? So we have water, we have computer, and let's say we have many more other types. And yeah, so what we can do here, so upcasting is already used here. Yes, since all of these waters, computers, and so on, they will all be passed to this method as product. Yeah, so upcasting will already be used here. Yeah, because all again water, computer, they all will be passed to the variable typed as product. Yeah, makes sense. So upcasting is already here, casting is used. But so let's say we have the product, we add this product. But we have one exception for the products which can impact our price. And so we see here we have this exception here, because this will impact the total price. Since if the customer wants to buy the computer and buy the additional warranty, extended warranty, then the customer needs to pay more. So the question is how to process these cases and how to calculate this price. So the answer is simple. I use costing, downcasting. I check if product is computer, and then I know that product is computer. Then I need to apply additional logic. Yeah, then what I do, I define another variable. Let's say that will be computer, and now I do the downcasting. Now I cast computer to product. Wait, sorry. Opposite way. So computer and product. Yeah, what do you do? Okay. So, and what I do, it's quite simple. I now add, and yeah, so then I check if computer has additional warranty. So if it's true, then I add the price of additional warranty to where is this? Sorry, that yeah, computer, of course, computer additional extended warranty price, and that will be it. Yeah, so this would be the example. Again, this is kind of dummy example, but is the idea here clear? Yeah, the idea is that we have the method, one place, which processes all the products, and then some of the products may have, and yeah, by default it's already, we use the upcasting, since we take all the products here. But we may have some exceptions, and then exceptions need to be processed as the exceptions like here, and then we may need to use the downcasting as well. Yeah, since we take the product, but this product has some additions we need to include in let's say in this case in our total price. Okay, if any questions. No? Yeah. So yeah,
I have a small question. I just
yeah.
don't see in the screen. Line for T, what is the symbol after quantity?
Which one? 14 or
40.
40?
Yeah, this
Yeah.
quantity, and then it
And
looks some kind of dark
multiply,
spot.
multiply. Yeah. So actually, to get the price, you multiply the price of one unit
Okay.
to quantity. Yeah.
Okay, just not good visible.
Yeah.
Okay, thank
That's
you.
the example. Yeah. So this is the quiet idea. I mean, in this case, it's just a small example inside one class, but in practice, this is how it will work. If you work with the frameworks, so you usually have the class, yeah, defined, and then this class processes all the possible options here, for example. Yeah. But I would say I just mentioned this example, and this looks, I would say, maybe quite understandable where we can use it. But yeah, if any questions, you can ask. I see Anakist, I think. Of course, this is not maybe ideal example. I will also zoom the screen. Okay. Yeah, sure. I can zoom the screen. Okay. Okay. So hope it's better. Yeah. In this case, we work with the classes, with the real classes, but maybe you will see after the break that such cases, for such cases, sometimes it's better to use abstract classes or interfaces. But okay, maybe let's have 10 minutes break now, and then after the break we will continue with the abstract classes and interfaces. And also, if you have any questions, then let me know after the break. Okay, so then let's meet at 10:30, 31, I guess. Okay. So let's have 10 minutes break. Yeah, I'll share this code as usually in GitHub, so if you want you can check it after the session as well. So, yeah, by the way, I need to check. Okay, let me try to run the previous program and let's see if this one will be available there. After that. It's so slow today. Maybe let me try to restart it then. It's okay. Just restart was needed, yeah, so just in case you don't see your current project under the solution, so try to restart it. Sometimes it may lag a little bit. Okay, do you have any questions about the casting? I hope that this example looks pretty much, again, on practice it can be extended with also in other options, like we can have warranty for computers. What else we can have? Oh, uh, not sure. Okay, maybe my imagination not is not the best one for now, but so I hope you can imagine yourself if so what kind of properties we can add to different kind of products and then how this may impact the content of the basket or the total price or something similar. It is relevant on practice. Yeah, maybe for now I can't imagine multiple situations, such situations, but yeah, this is what exactly where the costing, downcasting and upcasting may be used. Okay, so the next topic is about the abstract classes. Yeah, so initially this may be not really understandable why, yeah, the main question may be why do we need such kind of things like abstract classes and interfaces? Yeah, mostly this is about the abstract classes, but before we start I want to, let me check if the recording is still ongoing. Okay, so just we don't have any accidents. Yeah, okay, it's still ongoing. Okay, very good. So yeah, first of all, please, so in this case, in this section about the abstract classes, I want you to understand that the abstract classes themselves do not really provide any additional specific functionality. So abstract classes only provide they provide the pattern and the pattern what can be used, but it's not about the additional functionality. It is about the pattern, and to actually on practice it helps us make our code cleaner, more understandable. Yeah, so this is not about the additional functionality. This is mostly about the uh, the patterns we can use for the code. Yeah, and the patterns are really important for the codes because as I said, we may have the situations when we may have lots of questions about why this is implemented here, why this method, let's say, is implemented this way or another way, and yeah, so we'll see about the abstract classes. We may have the situation, like if we don't use the abstract classes, then we may have the situation then we ask the question why the method is empty. Yeah, so we define the empty method without any implementation. And to prevent, for example, to prevent such questions, uh, we can use the abstract classes. So yeah, but let's start with this. So first of all, about definition of abstract classes. How the abstract classes can be defined. So the idea of the abstract classes is, I would say, the same as for the usual classes. Yeah, so they don't have any. Yeah, the only difference is that the subclass. This is actually the question. The abstract class can or cannot be defined as sealed, so it cannot have the subclasses. I'm not really sure about this particular point because, yeah, because sometimes abstract classes can be used with for the static methods and attributes only. But okay, maybe let's check it a little bit later about the sealed. Yeah, we can define abstract class as sealed or not. But yeah, so in general, it is a simple class which has all the main attributes what the usual classes have. However, there are some exceptions. And so yeah, we'll talk about them today. The thing is that the definition, the abstract classes are defined the same way, but we just simply add uh, the attribute, the keyword abstract to the definition of the class. Yeah, and and yeah. So what are the rules of abstract class? Yeah. Firstly, again, remember the same rules as for the usual classes, but there are some exceptions. First of all, and the key point here is the abstract class cannot be instantiated, so we cannot have the object. Yeah, we cannot create the object which has the type of the abstract class. Yeah, so abstract class cannot be used as the type for the reference, as the type for the object. Yeah, and this is also comes from the name. Abstract means something abstract, something not really real, and so yeah, the same as same more. It describes this situation in the most precise way, I would say.
Is an example like a shape is in like abstract structure and triangles and circles is our objects of this shape.
Yeah, that's a good example because the shape cannot be really something real in real. Yeah, it's the way how we describe the triangle, how we basically describe the class of uh, of the shapes. Yeah, like triangles, circles, and so on. Yeah, this is a really nice example because the shape itself, I cannot really say to you, please draw me the shape. Yeah, you can draw triangle, you can draw rectangular, you can draw circle or whatever, but yeah, you cannot really draw shape because shape is just a definition of class. Yeah, that's a good point, good example. Yeah, this is something unreal. This is something unreal from the real life. Which I mean, not from maybe geometry. Let's say we can maybe also the class computer cannot really be can be abstract class as an example. Yeah. So let's say we have the class computer, and then we can define as the abstract class, so it's something abstract, and then we may have the real classes like smartphones, which can also be considered as the computers nowadays, laptops, personal computers, and yeah, and all the tablets, um, tablets and game stations and so on. Yeah, these all are the computers, and yeah, nowadays the computer itself it's something abstract. Yeah, for example, also the products. Yeah, so what can be actually the product? Yeah, we can have the foods, we can have the items like computers or whatever, and then these all are the products. But the product itself is something 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 abstract. Yeah. So and yeah, actually in this case we can also define product as abstract. Yeah, abstract class product. Yeah, and you see that in this case it changes absolutely nothing. It changes absolutely nothing in our example because yeah, we never try to instantiate product because we have water, we have computer, so water and computer can be instantiated, they can be created, but product itself not. Yeah, so in this particular example, I just shown you before, product can be an abstract class. Yeah, why not? Why not? Yeah, it can be. And I would say on practice, you will most likely see that in such situations, products will be defined as abstract class. In this case, the first point what I want to pay the readers of my code attention to is that the product itself cannot be the object. Okay? So we can have the subclasses of the product class, which can then be the objects, but not the product class itself. Yeah. So this will be the point. Okay. So yeah, and then the rules are that abstract class cannot be instantiated. Yeah, I cannot write the code where I create the object from product. So this is not possible because it's an abstract class. Yeah, but I can create the computer object, computer. Yes, I can. Computer is the real class. I can create uh, the object of water and so on. Okay, so this is the first rule. The first rule, and it makes sense because again also from the definition. Second point. Second point is an abstract class cannot have a sealed access modifier. Oh yeah, this is what I said, as it would make inheritance impossible. And to be honest, this point is maybe not really. No, I mean, it is correct from the technical point of view, but from the concept point of view, I would disagree that this is actually needed because, yeah, I will give you one example. Also, what I've seen only once from my example, from my experience, but I would say that this is quite this would be quite understandable approach. That let's say that you only need the class which has static members only. Yeah, so the class has only static attributes and only static methods. It does not. You do not want to use this class as the object. Yeah, so you only want to have this place where you call the static methods. So from real life, such class would be some kind of utility methods. Yeah, for example, we have this math class. Yeah, so you all know this before. Yeah, we have the system math class, and so we only have these are the static methods. Yeah, if I'm not mistaken. Yeah, these all are the static methods. Am I correct, right? They should be. Yeah, they all are the static methods, and so yeah, in this case, if everything is static, then the question is why? Yeah, so the question is then uh, how can I actually point out that I don't want? No, actually, it is written as a static class. Okay, then fine. Yeah, it's okay. It's stated as this is the static class. From my experience, that was with other programming languages, but if we if it's defined as the static class, then this is fine. Yeah, we point out that we don't create any objects from it. Yeah, this makes sense. But as another option, you'll see maybe in some other, maybe also in C# you will see somewhere. But yeah, the thing is that as an alternative to the static classes, you could define the class which has only static members, and then you can define it as sealed. Yeah, so then it just simply used as the class where you call the static members only. But yeah, this may be maybe more more advanced structure. Yeah, but yeah, I mean, also this point makes sense from the point of view that the abstract classes, like yeah, as I said, abstract classes cannot be instantiated, and then the only way how we can use them is that uh, we extend them in the subclasses. Yeah, so let's say we have subclasses, and then for subclasses in subclasses we extend these abstract classes, and then we use the properties of the abstract classes there. And yeah, that's why it is not allowed to use sealed sealed keyword, because in that case that won't be possible to extend the abstract classes. Yeah. And this makes this concept a little bit then broken, like if we don't have the ability to extend them. That's why it's not allowed. So then an abstract classes can contain abstract methods and properties. Yeah? And this is what I said at the beginning of this presentation, is that, for example, if you have a usual class, so let's say that I have the method which will be specific for all my subclasses. Yeah, but for this class, I have nothing general to define. Yeah, so for example, if I have the method which will then say public, maybe let's say that will be double. Yeah, maybe, sorry, that would be, maybe that would be string, get my description, for example. Yeah, so, and let's say that, so in this case, let's say that we have a situation when I cannot when I cannot really say anything about product, yeah, since I don't have any information here. Yeah, any information I may need, for example. And then, then if I have, and my assumption is that this method will be then implemented in the subclasses. Yeah, so here I don't have any specific logic I can use, but in the subclasses, yeah, so I assume that this method then will be implemented in the subclasses. Yeah, so this is my This is my assumption. This is my this is actually what I want to the way I want to use this method. Yeah, so I don't want to define anything specific here in the parent class, but my assumption is that this method will then be, oh yeah, so that would be, let's say, public virtual, then of course virtual. Yeah, so then my assumption is that this method to be overridden in the subclass. But you see that it looks strange a little bit, yeah. So it may look unclear for those who implement this method. For those who see this code, they may not understand why something like this is used. Yeah. So why do you actually intend to create the empty method without any purpose, right? So this looks a little bit unclear. Yeah? So if you see something like this. And as an option to prevent such cases, we can simply define abstract class. Then we define the method as abstract. Then we don't define any logic here, and then it would be clear. Yeah. So in this case, I say that okay, this is the abstract method. And if the method is abstract, then we automatically point out that it should be implemented in the subclass, in subclasses. Yeah. So this will be automatically, directly, and everyone will understand. But then you see that now we have the errors, and what these errors mean. These errors mean that that the method, the abstract method, must be implemented in these classes. Yeah, so if we define abstract method, then at the point when we reach the usual class, yeah, because on practice what we may have the situation when the abstract class has the subclass which is also the abstract class. Yeah, and yeah, such case is also possible that abstract class extends another abstract class. This will be possible, but yeah, this will actually be possible. And then the thing is that when we reach the point when we have the class which is not abstract class, then at this point we need to implement the logic for the abstract method. So what I can do, I can simply say public override my description, and then I can write my logic here, or yeah, you see there is this default exception that the method is not implemented. Yeah, this is also the feature, I would say. Yeah. Where is this? Go on. Yeah. So you see that yeah, this is the feature used in C# that you can throw this exception not implemented exception. This means that when this method is called, then it will actually trigger this exception. Yes, so in practice this can be used in some way, like if we define these methods somewhere, and then you use the objects and then you call these abstract methods, defined as the abstract. In the superclass, then you can handle this exception as an option. Why not? Yeah. Okay. So yeah, abstract methods and also properties. Not really properties. I mean the properties of the abstract methods. Okay. The non-abstract class derived from an abstract. Yeah. By the way, you also see that inside the abstract classes we can also define the usual methods. Yeah. So where's my class? Okay, where's my, yeah. So you can also define usual methods here as well. Let's see, my usual methods, yeah, so I can define my usual method and do some code here. That is also possible, so if needed, then you can also define the usual methods inside the abstract classes. Yeah, so non-abstract class derived from the abstract class must include actual implementations. Yeah, this is what we just done. If the abstract class is, so if the abstract class is extended, then all the abstract methods extended by the usual class, which is not abstract, then these abstract methods need to be implemented then, and they need to be overridden. Yeah, must include, yeah, thereby overriding those abstract methods. So it means one more thing, what you need to remember and understand that all the abstract methods, they are virtual methods by default, yeah, because otherwise it doesn't make sense. Like if the abstract method is not virtual, then actually there is no sense of this method. So because I have nothing to do with this, I cannot really do anything with this abstract non-virtual method. Yeah, so since I cannot override it, so the question is, what can I actually do with it? And the answer is I can do nothing with it. That's why by default, yeah, maybe I'll point here, not by default, but in general, all abstract methods are virtual. Okay, a class that has at least one abstract method, whatever is declared ahead from master class, must be declared abstract. Yeah, so see that to point out that the method is abstract, you need to declare it as abstract. If you don't do it, then you need to provide the implementation. Okay, so then the next rule is that the implementation provided by an overriding method, which is general member of non-abstract class, yeah, the implementation should be provided. That's the point. You may not use the static or virtual modifiers in abstract members since, again, that makes sense. As I just said, the abstract method cannot be virtual and also cannot be static, because static usually it also means that you cannot override it. Yeah, you cannot override static methods because it doesn't really make sense. Since again, as you remember, abstract static methods, they belong to the class. Yeah, so it means that I can access, like if we say class A implements static method, then and then class B, which extends class A, you can then simply call this method from the superclass then. Yeah, separately from the class A. This would not go with inheritance in some way. Yeah. That's why static methods, virtual methods cannot be abstract methods. Non-virtual methods cannot be abstract methods. Okay, so then use the abstract modifier method or property declaration to indicate that method or property does not contain implementation. Yeah, this is what we need to do. And an abstract method is implicitly a virtual method. This is what I just said. Yeah. So, yeah, this is how it may look like. Yeah, we have, yeah, as I said, we have abstract methods and abstract properties. So for abstract method, we just seen simply we can define the abstract method inside the base class, inside the superclass, and then we can implement this method in the subclass. Option. So it needs to be implemented there. For the property, yeah, if the property is defined as abstract, it means that it should also be redefined in the subclass. Yeah, and then, because otherwise, yeah, let's see what happens if we define a property as abstract and don't redefine it. Public abstract. Sure. Property. So I define get, and maybe also I define set. So you see that it also requires to redefine then this getter and setter. Yeah. So that's why it needs to be redefined, overridden. So sometimes I use the term redefine instead of override. So this is also the synonym of this term you can face in practice. Yeah. So be careful, but yeah, so I hope you know this one now. Yeah, so quite simple here. So do you have any questions about abstract class apart from the question how these classes can be used? I will explain this a little bit later. So from the technical point of view, yeah?
Yeah, hello. I actually have a question a little bit back. You mentioned again the virtual classes. I wanted to ask, it's basically they can use if they are derived from other class. Does I understood correctly that if we think in terms that we have superclass and
Yeah.
subclass, then virtual method will be always used only in subclasses, not in superclass, right? Or
No, I
maybe you
mean,
can explain better a little bit.
virtual methods can be used in both classes. The key point for the virtual method is that it can be redefined or overridden in the subclasses. Yeah, so we define, let's say, public or protected virtual method. Then we go to the subclass. Inside the subclass, we can redefine it. We can change the behavior of it. Yeah, so we can override it. So if we
Okay, thank
if we
you.
use public override, then it means that we can override only the virtual method. And the thing for abstract methods is that actually we by default, so by default and by theory, we must redefine, override all these abstract methods from the subclasses, because abstract method means that it does not have any implementation. So that's why if the method does not have implementation, so the question may be how can we use it if it cannot be redefined. Yeah, that's why by default it should be virtual, not by default, but so just yeah, automatically it is virtual method. Method is abstract, because otherwise it doesn't make sense at all if we can't override it in the subclass. Right? This is why we have it. Okay, any more questions? Okay, then the next point would be the interfaces. So yeah, remember earlier I said you about C++ and that it is possible to use multiple inheritance in C++. So it means that you can inherit from multiple classes, so to an extent multiple superclasses in one class. But in C# it's not possible. Yeah, in C# it's not possible. Again, I think I mentioned you the key disadvantage that if we have the same methods in both superclasses, then the question is which method then needs to be called from the subclass then. That is the issue, and so yeah, instead of multiple inheritance in C# we have the the interfaces. And yeah, so interface defines a contract by specifying a set of method prototypes of which each class that implements must implement them. So yeah, this we have multiple, but we have several usages of interfaces. So the first point would be that inside the interfaces we define the methods. So then we can use this interface as a part of other class, and then these methods need to be redefined in the class. So but it means that actual interface has all the abstract methods. So all the abstract methods, all the methods are abstract in interface, and then it simply means that when interface is applied to the class, if it is abstract class or whatever, then these interfaces are actually inherited by this class, and then if the class is not abstract, then it should implement these methods, what are defined under the interface. Yeah. Yeah, this is one usage that defines the structure what then can be applied to the class. Then there is the second way of usage, and the second way is maybe more interesting. It is the marker interface. Yeah? So on practice we have the marker interfaces, and what does it mean? It means that we simply, so maybe I can also provide this example here. So I say that so I defined the interface, say my marker, yeah, and I just simply don't provide any implementation. Then what does it mean? It means that, for example, let's say we define it under the water. Where's water class? Yeah, so let's say I implement. Sorry, yeah, I put this interface here. So let's say I implement. Yeah, this interface has nothing. It's just simply empty interface, and then I assign it to the water class, and then what we can basically say, for example, somewhere I can check if this particular object has this mark. So let's say if product is my marker, so if it has this marker assigned, then maybe I can print that the product is marked, maybe let's say as something, yeah. So it is marked. Yeah. So basically, this puts such way of marking certain objects. Yeah, we can mark the objects using the marker interfaces. Yeah, so because actually you see that the interface has nothing, yeah, so it's just simply empty interface, but we can then we can then apply this interface to some classes, which we want to mark as something. Yeah? So let's say that just simply mark something. Yeah? So yeah, maybe group them as an option. Yeah? So let's say we have two groups of product classes. Yeah, we have, let's say, group A and group B. Then we can assign one class, one group of classes as they mark as group A, and then mark another group of classes as group B, for example. So, and then just then in the code we can simply then check if the marker is applied to the product. Yeah, as it is here. Again, in theory, maybe let's maybe do it in a more smart way. Then let's say that will be group A, and group B, and then let's check if let's say that the water belongs to group A, for example. And then computer, let's say, belongs to group B. And then I can maybe apply different logic for different groups of products. Why not? Yeah. So if product is group A, the product is, yeah, we can do some logic here. And then we can check if product is in group B, then we can simply apply different logic. Yeah. Yeah, so again, these interfaces have no logic, yeah, but they can be used as the markers for different classes. Marker interface. Yeah. The same I would apply to group B. So yeah, this would be one of the usages. And yeah, so by default it is 100% abstract class because, again, for the abstract classes, the percentage of abstraction can be from 0 to 100. Yeah, like it's also possible that we define all the methods as abstract in abstract class, but we can, if we want, we can define some methods as non-abstract. For the interfaces, it is exactly that all the methods are abstract methods. Yeah, so this is the exception. And then you can simply imagine the abstract class, which has all the methods defined as abstract, and then this would be the interface. This would be the interface then. Yeah. So it provides a form of a class, but not how to implement it. Yeah. So that's why we say that we do not extend the interface, but we implement the interface. Yeah. So there are some differences in terms here. In terms we use. Okay, and yeah, an interface defines what a class can do, but not how the class will do it. Yeah, so as I just said, we only define the structure. Yeah, the structural definition for which then can be used inside a class. Yeah. So an interface can inherit from multiple base interfaces. So it is also true all the interfaces can inherit another interfaces, same as the classes. So they have, I would say, similar rules for the inheritance option. Yeah, so they can inherit another interfaces. Then they can contain methods, properties, event, and indexers. The interface itself does not provide implementation. Yeah, this is what I said. Actually, everything is abstract here. And the class or structure can implement several interfaces. Yeah, so this is also true, and this is where we achieve such or a kind of multiple inheritance. What is available in C++. Okay. So in C# we have the interfaces. In C++ there are no interfaces, but there is multiple inheritance. So yeah, the explicit base interfaces of an interface must be at least as accessible as the interface itself. Yeah, so yeah, they should be accessible. So it means that we can. So they are available for the code. The base interfaces of an interface are the explicit base interface and their base interfaces in turn. So yeah, let's see the example. So we have the interface, one interface, then the interface may extend another interface, so then another interface may extend this interface, then then we have another sub interface and another sub interface. Yeah. Yeah. This is what you can see. So and basically the same as for the classes. If we have the method defined here, then this method will be inherited in the structure. Yeah? So you see that it has no implementation and should not have, but it is then inherited by the subclass. Yeah? And this is acceptable. They will be inherited. Same as for the classes. So the rules are same. And yeah, and the interface cannot contain constants, fields, operators, instance constructors, destructors, or types, nor can an interface can contain static members of any kind. Yeah, so only the structural definition for the methods and also the properties. Yeah, so you also see that for the abstract class, we can have the access modifiers for the methods, for the members. So it means that the methods can be public, the members can be public, protected, or private. So we can limit the access to them from outside. Yeah, this is the same for the abstract classes. This is the same as for the usual classes. So the rules are the same, but for the interfaces, the rules are a little bit different. And yeah, one more thing what was not said before for the abstract classes. For the abstract classes, we cannot have the private abstract methods. This makes sense. Where is this? Yeah. So we cannot have private. I see. Abstract method because it doesn't make sense. It doesn't make sense since, again, in this case we cannot we have no place where we can override this method. Yeah, because if the method is defined as abstract, means that it needs to be implemented somewhere. But in this case, if we define it as private, then it means that it cannot be accessible from the subclass. So it has no place where it can be implemented. Yeah, where we can override it. So that's why we are not allowed to define the abstract method as private, but we can define it as protected if we want, yeah, or as public. Yeah. And comparing to the usual classes and the abstract classes, interfaces have only interface members have they have public access only. They are all public by default, and they cannot have anything else. Okay. So do you have any questions so far? Okay. Then we move on. And implementing an interface means that the same as for the abstract classes, we override the methods defining the interface simply by providing the implementation. Yeah. So interface and implement using semicolon, using colon, the same as the superclasses, same as usual classes. So we basically can simply provide them in a row here. Yeah, so after the column we can put the superclass, and we can also put one or multiple interfaces. Yeah, so this is the key advantage for the interfaces. They can we can have multiple interfaces implemented under one class. So this is their advantage. And then yeah, cannot narrow the member accessibility, so we cannot change change the access modifiers for them. So yeah, this would be the example. Let's say that we have the interface for bank operations. Yeah, so and yeah, this is actually the answer to your potential question about where the interfaces can be used. So for example, let's say that we have the interface bank operations. Yeah, so let's say that we have the application which implements the bank. Yeah, for example. Then let's say that this this application then has the classes. Let's say it has the interface bank operation. Then operations. Then what we can define? We can define the operations what we can use. So that would be withdraw, deposit, balance inquiry. So we define the structures of the methods. And what this basically means, it then basically means that this interface can be implemented somewhere. Yeah. So for example, here we have the so let's say we can also have the abstract class. Yeah, the abstract class has getter and setter of balance. Then it has one additional abstract method. Yeah, print account info information. And then first what we must do here. Yeah, if we have this abstract class defined and also the interface defined here for the implementation, we must implement all the abstract interfaces, or sorry, all the abstract methods. What we have here, we have only one abstract method, so we must implement it, and then we also must implement all the methods defined under the interface. So this is what we must do, and this is what is done here. And the methods are implemented. Yeah, and yeah, they all are implemented, and now this class can be used. Yeah, and here again, here we also have the option of casting, because casting also works for the interfaces as well. So what does it mean? It means that if the class implements the interface, then it means that we can define the variable with the type. Let's say here we have bank operations, and then we can define this variable. So let's then maybe have the example here. Okay, I need to I need to implement class. Public override. Yeah. So that here we have one. I would say we have here one issue, but I guess this issue is interesting for you. So you see, we have the warning here, and the question is, what does this warning mean? So you see that we have this print account info defined as abstract here. Yeah, this is abstract method. And remember what we were talking about last time, when we talk about polymorphism. Remember, we can define a method like if we have virtual method defined in the superclass. Remember that all the abstract methods, they all are virtual methods. So, and remember what we can do with virtual method. We can override it. We can keep it as it is, or we can create new method. That's what means that we can use new operator. And in this case, you see that it is nothing provided here, not new, not override. In this case, the program will give you the warning, and because in this case it does not understand, no, actually by default it will take simply new, but at this point it does not understand if you want to override this method or you want to create new method. Yeah, that's why we have two options. We can write new or we can override it. Yeah, if we use new, then this will stay. The error stays here that we need to implement print account info. Since yeah, this is also a really interesting point. If we define, like if you want to implement the abstract method, then you cannot define it as new, because in this case it simply means that you have not implemented this method yet. Yeah, that's why you can only use override, because new means that you create new method, you create new input. This is, yeah, you create new method, and these methods are not related with each other. Yeah, abstract method defined in a superclass that would not be related to this method if you define this method as new. So it means that all abstract methods, yeah, so maybe I'll also give you the comment here, all abstract methods must be implemented, and you must use overrides. Root, no, override keyword. Yeah, because otherwise that one will not be correct, since all the abstract methods must be implemented. Yeah, and let's then define bank operations interface. Yeah, so maybe I will rewrite it from here. Bank interface, bank operations. Then that would be withdraw. And then double amounts. Yeah, I cannot write implementation because all the methods here are abstract. And yeah, by the way, here I don't need to write public since they are public by default. Okay, then the next one would be what's deposit. Double amounts. And yeah, next one is double balance inquiry. Yeah, so now I can use this interface, which then simply means that it will put the structure of the definition of these methods into the savings class. Yeah, and then the same as and then the polymorphism is can also be used here. So for example, here we can define the variable operations. Yeah, and then we can define. Yeah, we can create the object savings and pass it to the bank operation. So say polymorphism and upcasting is used here. And in fact, polymorphism here works absolutely the same way as with the usual classes or the abstract classes. So if the class implements the interface, like in this case savings implements the interface bank operations, then we can cast savings to the bank operations. That's fine. That is correct, and this is the same as for the usual classes. Yeah, so here we do the upcasting, and this will always be correct. Same as for the downcasting. Yeah, so if we want, then we can pass bank operation to savings. So then we need to do the casting. So this will also work this way. Yeah, I can also check if bank operation is savings. Yeah, so I can also check this point. So maybe let's then do it this way. Yeah. So what was this? Yeah. So in this case, it doesn't make sense to write it this way. Yeah. Why it shows the error? Because I have only one statement, and this statement is definition. It means that I cannot use this variable after that. Yeah, that's why it shows me the error, because yeah, I have no possibility to use this variable anywhere else. That's why it shows the error. So I need to then declare the variable here, and then I can pass it here. Yeah. So all the same rules. Yeah. All the rules for the interfaces are the same as for the usual classes. Okay. So, do you have any questions? Let me then move the presentation back. Yeah, so here I have three components: interface, abstract class, and usual class. I can combine them all and then reuse them. So the usage is quite simple. We define the structure, which then can be applied to any class. Like in this case, I applied it to savings. Then I can also apply this to the bank service class. Yeah, so where the customers are served, or maybe ATM, for example. Yeah, so we have one class, and then we have another class. Sorry, that's the wrong program. Then let's say I have the class ATM. So it also is the bank operations, and then I can implement these methods here. Yeah, so implement the methods. Override. What do we have like draw. Sorry, yeah, public overrides. What was the returning? No, that was void. Sorry, yeah, public override voids. Throw. Oh, sorry, yeah, this typo. Yeah, if you want, you can do the following way. You can copy paste in this way, and then simply add override to them. Yeah, I'm not sure why the hotkeys do not work here. Okay, public. Override void withdraw, and then I can provide some logic here. Yeah, this public override. Okay. Oh, one moment. Okay. Yeah. So, okay. Yeah, I don't need to write override for interface. Yeah, it was just so yeah, it was just confusing. Yeah, for the yeah, you see that for the interfaces we don't use override. And so this is one small exception. Yes, because that should be override for by default. I cannot really say why it is this way, but yeah. So for the interfaces, we don't use override. So that is just the point. Yeah, so here we can write the logic here. Same as here. Yeah, public void deposit, and then yeah, I can also override it here. And then I can return some number here. Just done. Yeah, so as an option, yeah, bank operations can be used in one class, they can be used in another class. And the advantage of the interface is that they can be combined with other classes. Yeah, with other classes and also with other interfaces when we implement them. Yeah, so this is the key point of usage of interface. They can be combined with other superclasses. Yeah, and also other interfaces. Do you have any questions? Okay. Then we have another example. Let's say that we have I can jump interface, which jumps, I can swim, I can fly, and so on. And then we have, yeah, let's say the hero, which implements all these interfaces and yeah, then the hero class implements them all. Right? And yeah, and for example, another class, let's say it implements only one interface, then it needs to implement only one method then. Okay? And yeah, one more thing what I told you before is about the multiple inheritance. So when we have, like in C++, we have this option to extend multiple classes. In C# we can implement multiple interfaces. And then let's say that we have another interface which also has the, let's say, what would be the interface? My card, my credit card. Interface, credit card. So, and let's say it also has the method deposit. So then the question would be, what will happen if we also implement this interface? Actually, that will not result in any conflict, since we have, basically what happens, we have method definition here, we also have method definition here. These method definitions are both the same, right? And so there are no conflicts if they both are, they are abstract, they don't have implementation, and they both are inherited here, yeah, for the class savings. So then this method is inherited and this method is inherited. But since they are the same, there are no conflicts, right? Because they both are the same. Yeah, so there's no question which one should I use, since they both are the same. I can use any of them. So yeah, this is the point for the interfaces. They don't have implementation. That's why the compiler does not have the question which one to use, since they both are the same. And so this is the point of multiple inheritance for the interfaces. Yeah. So yeah, this is the point. This is the point. Then, do you have any questions here? Okay, then we move on. So yeah, then we move to the question: what are the differences between the abstract classes and the interface? So, and first of all, as I said you before, abstract classes can have the 0 to 100% of abstraction. Abstraction means that we have abstract members. Interfaces do have 100% abstraction, so it means that we cannot implement the interfaces there. Yeah, and then the question is when I need to use the abstract class and when I need to use the interface. So the abstract class can be used if I want to provide some generic implementation, but something, some members can be abstract. Yeah, so for some methods I do not provide the implementation. For some members I do not provide the implementation. And yeah, then if I want to add some attributes, yeah, I can do it only in abstract class. I cannot do it in the interface. See, I cannot define here, let's say, the member my balance double my balance, and I cannot do it because for the interfaces I'm not allowed to define the attributes. I can only define the methods. This is the point. This is the point, and that's why in case you need to use you need to have the attributes, then you need to use the abstract classes. So on the other hand, if you want to use interface type, then you need to enforce certain interface to be implemented by a class. Yeah, so when you but first of all, key point for the interface is that comparing to the abstract classes or any other usual class or any other classes, you can only you can achieve multiple inheritance using the interfaces. So this is the key advantage. Yeah, so I can define as many interfaces I want here, in addition to the superclasses, but I can define multiple superclasses here. Yeah. So this is the point. This is the point when I need to use interfaces. And again, also apply all the rules of polymorphism here. They are all relevant in this case as well. Yeah. So. Do you have any questions? Okay, then the last one would be about the sealed classes. So this is not about the abstract classes and interfaces, since, as I said, abstract class cannot be sealed, yeah, because it doesn't make sense. But yeah, in general, sealed classes means that they are complete and you cannot define the subclass from them. Complete and cannot be improved or specified. You cannot inherit from them. And to reuse them, you must utilize composition instead of inheritance. Yeah, so it means that I cannot have the subclass of sealed class, but I can create the relationship. Yeah, so for example, as I said, we can we can say that for example, we have the class person and the class, owner and the class car. We cannot say that the car is or can be the subclass of or owner of person, but and we can also not say that the person owner can be the subclass of the class car vehicle. That is not possible, but we can define these relationships. Yeah, that owner has the car and car has the owner. Yeah, we can define such relationships. And yeah, also sealed classes can be used as a part of the relationships. Yeah, we can then define that. So let's say we have sealed class A, then class B can store the property, the member, which is then this class A, which is sealed class. And the roles where it cannot be extended. So as it cannot be extended. What I said. Or subclass, it cannot be an abstract class too, since it doesn't make sense. Yeah. And all methods of sealed class are implicitly sealed methods. Yeah, so they cannot be virtual. And this is the point. Sealed class example. I don't. So I guess I don't have it. So this slide. Let me check. I guess I don't have it. Let me quickly check. Yeah, I don't have it. So maybe we can then skip this. Yeah. So the difference between abstract class and sealed class. So abstract classes, they provide the template of behavior for the subclasses. Yeah. So the same as all the other classes which are used as a part of the inheritance, but with some additions. Yeah, with addition that the abstract class cannot be used as the object itself, and basically sealed class is the total opposite of the abstract class, because sealed class should be full class. It cannot be extended. It should have all the implementations. It has 0% of abstraction. It has 0% of the way that something can be inherited and overridden. So everything is defined as, like, let's say, final implementation of the class, and it cannot be extended in some way. Yeah, so these are actually two different opposite sides of the programming. But yeah, this is, I would say, mostly about the practical usage and about the patterns of how you define. Yeah, so at this point, can I really imagine a good example of sealed class? Let me think. Maybe at this point, not. Maybe let me quickly check if I can. Sealed class. Yeah, okay, we can find some generic examples. But yeah, I mean, for this at this particular point, I can't really define explain in particular case. In practice, this is usually based on your usage. Yeah. So for example, you define your own framework, or your own framework of the classes, and at some point you have the class which you define as, okay, this is the final class. It cannot be inherited. It cannot be extended. So it should be, actually the hierarchy should be closed at this particular level. Yeah, so yeah, it mostly depends on you, and what you'll see this on practice. You'll understand it when to use it. This mostly depends on your particular wish of wish how you want to define your own framework, structure of your own framework, or your solution, to be more precise. Okay. Do you have any questions? Okay, then maybe let's have 10 minutes break, and after 10 minutes after the break I will explain you the task for you then. Okay, so let's have yeah.
Actually, what is in the next slide? Key points?
These are the key points, the overall of all this presentation. Yeah.
Okay, we
So
can
this
check it.
is I mean, I maybe I prefer to then to explain yeah, this is mostly the recap of the presentation, but I prefer then to give the recap of the previous presentation during the next session, just for you to introduce where we are, what happened last time, and maybe to summarize what happened during the previous session. I can summarize it during the next session. So I think it's a better approach so you understand.
Okay,
So
thanks.
you remember what we did last time, and also maybe give something, some key points for you. That's why I move. Usually I always I move the summary to the next session so you can remember what happened what happened before. Yeah. That's why I skipped this slide and then go back to it next session. Yeah. I will share this presentation with you. I guess it's not shared yet, but yeah, maybe right now let's have 10 minutes break and then I will come back to you. Okay, so then let's meet after 12, it's 12:02 that will be. Okay. So now I will push the changes then to GitHub then. So, hold on. No, fine. Okay. Okay, so yeah, I just pushed all the changes to GitHub so you can take a look on them there. So, okay, then the task for you. The task for you, I shared the activities 4 and 5 in the chat, so please open the folder and you'll see, yeah, there are 2 activities there, activity 4 and 5. So yeah, so please then proceed with both of them. Yeah, so the idea would be the same as for the previous activities. You create new, yeah, let's say we create new project here. That would be class library, same as before. Yeah. So we define class library. I define it as activity 4. So then we create the solution. So that will be here. Yeah. So then I create it. And then I delete this class. And I need to implement array store. Moment, let me open the files. No, hold on. This one. Okay. So here I have these files. And so I need abstract array store here. Yeah, I need to add abstract array store, and you need to follow the instructions here. Okay. So please then proceed. So it's not like you need to finish it today. So I would say that maybe the term would be, so where is this moment? Yeah. So the term would be, what was the previous one? Moments. My previous messages. Moments. One moment. Oh no, practical tasks, yeah. And the practical tasks. So then let's say I want you to submit it, let it be then until maybe Wednesday then. So have time now. Then I hope on Wednesday that should be fine. Or no, maybe let it be Friday. No, wait, let it be next Saturday then. At least no rush for you, also no rush for me. So then that would be that would be activity 4 and 5. And 5 until 27th of November then. Yeah, but right now you can proceed. I'm here, and so just in case you have any questions, then you can ask me. Meanwhile, I will check. I will then check the the tests. Okay. So then please proceed, and if you have any questions, let me know. Okay. Mm-hmm. Mm-hmm. Hmm. In case you have any questions, I'll be back in 5 minutes. back in case you have any questions. I see there's the question from Alina. To make sure I have understood that completely, we have to create a new class array store, and in this class we have to write a code for methods from the abstract class. Yes, we have the abstract class abstract array store, and a moment, so just to not mix anything. Let me maybe open them. One moment. Yes, you need to create. You need to create yeah, array store class, which then implements this particular class. Yeah. Yeah, this is correct.
I wanted to ask a question.
Yeah.
So basically, we have to take from the base class, and it is abstract, and it has a private parameter.
Yes, abstract classes, they may have the private parameter.
So
Yeah.
it should be overridden.
You cannot override private parameters. You mean which parameter?
The actual store array that has to be used.
Yeah, and so what do you want? What do you want to do with it in the subclass? The idea is, yeah, if the attribute is defined, yeah. So this is also one of the theory points I wanted to. I said to you before that even the private attributes, they are not accessible for the subclasses, but they are still inherited. So it means that it will still be there, but only the properties of the abstract class will be able then to access
Okay, so then
So it actually means that it is accessible from this class. This is correct, and you can also use some public or protected methods from this class to access it, but you cannot access it directly from the
okay,
class.
okay.
Yeah, that's the point.
For some reason I wanted to do something, but I guess I don't need to do anything with it in the
Yeah.
other class.
Yeah,
Okay,
I
thank you.
mean, but yeah, actually, that's a good question because this may be also a little bit unclear for the beginners to understand when understanding the concept of object-oriented programming. Because as I said, the difference is that we cannot access the private attributes, but the private attributes, they are still inherited. They are still inherited, so it means that the object, which is the sub, which is created based on the subclass, it still has all these attributes, but they are not accessible for the subclass. Yeah, this is the only difference. They are not accessible. But usually the workaround is that there are the public, or if we talk about the subclasses, protected methods, which then can be used to access these private attributes from the superclass. Okay. Okay, the question from Owen, because I wanted to try and write add methods, I wanted to add an element to a store array, but it is a private. Yeah, but one moment. We have the index off. That's fine. But yeah, so here you have the public virtual set method, so you can use this one. Yeah. So actually, you don't need to access this array directly, but you have this method. So you have setter here. You have setter here, which actually does what you need. Yeah, this is interesting point. Yeah, so you see that when you create the, like, again, imagine you have this abstract class here, then you have the subclass which implements this abstract class, and then imagine you create the object, like in your case that would be, here we have array store. Yeah, you create the object of array store, but it still has this this parameter. It is not accessible from the array store class, but it is accessible from the methods of this class. Yeah, all the methods of this class can access this store array. And for example, you have the public, have the public method here. Yeah, so public setter and public getter, so you can access them from your subclass or even from the class which is not related to this class. Then access them, and so they will simply, this is the way how the program will access this private attribute in this after class. Yeah. So this is so-called way around, and this is how it is usually the same for getters and setters. Yeah. Attributes themselves can be private or protected, but if the getters and setters are public, then it means that we can access them publicly as well. Okay, so I checked your tests. The results look to be pretty good, I would say. And yeah, so let me then maybe share the results. I guess I can share them here. Also alongside with the other home tasks. So let me then maybe do it here in chat. Yeah. So and yeah, so the last one moment. Sorry, I forgot to include the first line. Sorry, you can adjust this. One moment. Okay, here we go. Okay, so and yeah, the maximum number of points is 19. Yeah, so one for each. One for each question. Yeah, so the results are pretty good, I would say. And yeah, maybe I will share the the answers maybe also here. One moment. Yeah. So there are, yeah. So the test answers are here. A moment. Let me then share them. Yeah. Okay. So here there should be the answers. And maybe I suggest then we can discuss the key points here on Monday then. Okay. So we can take a look. Yeah, so no rush, not now. Maybe until Monday, please take a look, and then we can discuss all these points on Monday. Then, yeah, we'll go through this knowledge check. Okay, so do you have any questions now? So okay, then I give you the time so you can go through the knowledge check then, and yeah, then you can prepare the questions for Monday. Okay, and so anything else for now? Do you have any questions? Okay, then if not, I think that would be it for today. I wish you all nice remaining of Saturday and also nice Sunday, and then meet you all on Monday. Okay, so thank you very much and have a nice weekend ahead.
Yeah,
Bye.
thank you. Bye bye.
Thank you.
Bye bye.